Tracing the loop and finding the area. The question is, trace the following loop and find the area covered by the loop. For solution, first of all we have to trace the curve. Given curve, for this we have to find some important points, whether this passes through origin or not. The point on x-axis, by putting y is equal to 0, we get the 2 point 0, 0 and a0 in the x-axis point. Similarly, for the point on y-axis, we get single point 0, 0 in y-axis, and the curve has even power of y as y square, so it is symmetrical about x-axis, and the curve become this. The loop is the closed curve starting from the single point and return back to the origin. It is symmetrical, so the initial curve look like this. And then we have to find the tangent at point extreme point of the loop. For this, equate lowest degree term of the equation to 0, we get a y square minus ax square is equal to 0. Y square and x square are the lowest degree term of the equation, and we get the tangent at origin as y is equal to plus minus x. Similarly, to find the tangent at point A, we have to differentiate the curve and find the first derivative at a0, which is 0. So the tangent is vertical at the point A. Then this is the tangent at A as well as origin. We have three tangent, so the nature of the curve is determined by the tangent. Also, it is not complete. To complete the curve, we need to test whether the curve exists beyond the loop. First of all, we have to check when x is greater than a, the curve becomes positive. In this region, x square is positive, and this second term a minus x is all negatives. So y square become negative value, and it produces y is imaginary. So there is no curve when x is greater than a. Similarly, when x is less than 0, that is for negative value of x, and the y square become positive. First one is positive, the second one is also positive. There is minus x for negative x, this become positive, and y square positive means y produce the plus minus real values. When x is negative, it produce the positive and negative value, since curve is symmetrical about x-axis. So it means there is a curve left to the origin, and the curve look like this. For every value of x, there is positive value as well as negative value. When magnitude of x increase in the negative direction, the magnitude of y also increase, so curves extended up to infinity. Now, the second part of the question is to find the area of loop. The loop, the region loops only, the area of loops only. So area is equal to 2 into upper part of the loop. Area is calculated based on the x-axis or y-axis. In this case, the reference point is x-axis, so 2 into upper part. The formula is y dx from 0 to a. The range is the end point of this curve. At point origin, the value of x is 0. At point A, the value of x is a. The range of integration is 0 to a. We restore the value of y from the equation, and then equation become this. To further calculation of the area, let x is equal to a sine square theta, which implies theta is equal to sine inverse root x minus a. This is for the calculation of the range of the theta. On differentiating with respect to theta on both sides, we get dx, the value of dx, and we need to change the range. So when x is equal to 0, this equation gives theta is equal to 0, and when x is equal to a, this equation gives theta is equal to pi by 2. And then from by restoring the value, we obtain these types of equation. These types of equation can be solved by using the beta function, and the value of beta function is evaluated by converting it into gamma function, and we have the relation of gamma function. Gamma by 2 is equal to 1 by 2 into root 5. Similarly, gamma 7 by 2 is 5 by 2 into 3 by 2 into 1 by 2 into root 5. On simplification, the area of these loops become 8a square by 15 square unit. This is the area covered by the loop. We can calculate the area from minus a to plus a, minus twice a to plus a, and so on. If the question asks in the this region also. This is the area of a loop.